April 7, 1945. Flight Sergeant Isamu Totanimutsu gripped the control stick of his Nakajima K-84 Hayate as he climbed through the morning sky over Tokyo. At 23 years old, he was already a veteran by the desperate standards of 1945, having survived 3 months of combat when most replacement pilots lasted 3 weeks. Below him, the morning sun painted Mount Fuji's snow-capped peak in shades of rose and gold, its perfect cone rising from the landscape like a sacred monument to eternity. The scramble order had come at 0630 hours, enemy fighters approaching from the southeast. Totanimutsu had initially thought it must be a mistake, perhaps carrier-based Navy fighters from the American fleet offshore. Those he could understand, even respect. But the radio chatter from ground controllers told a different story. Land-based fighters, single-engine fighters, coming from impossibly far away. His squadron commander, Captain Yoshida, had assured them just days before that American fighters could never reach the homeland from their island bases. The mathematics were simple. Iwo Jima sat 750 miles across open ocean. No single-engine fighter had that range. It was physically impossible. Japan was safe from fighter attack. The B-29s might come, but they would come alone, vulnerable. At 25,000 feet, Totanimutsu's engine began to labor. The Nakajima H-45 Radial, theoretically capable of 2,000 horsepower, coughed and wheezed as its single-stage supercharger struggled to compress the thin air. Black smoke trailed from the exhaust, visible evidence that the fuel mixture was running rich, wasting precious gasoline Japan no longer had to spare. The engine shook the entire airframe, vibrations that made his instruments blur and his teeth rattle. Then he saw them. Through the crystalline morning air, silver shapes caught the sun. Dozens of them. Not the familiar round-bodied shapes of Navy fighters, but sleek, purposeful machines with distinctive bubble canopies and invasion stripes painted on their wings. They flew in loose formations, supremely confident, as if they owned the sky above the Emperor's palace. Mustangs, someone breathed over the radio, the word spoken like a curse. American Mustangs, over Tokyo. In that moment, Totanimutsu felt something break inside him. Not fear exactly, something worse. The cold certainty of defeat. His commanders had promised the divine wind would protect Japan. They had sworn no enemy fighter could reach the sacred homeland. Yet there they were, P-51 Mustangs, land-based army fighters that had somehow crossed 750 miles of open Pacific to appear over Mount Fuji itself. When I saw the Mustangs with my own eyes, he would later recall, I thought I was dreaming. It was impossible. Our commanders had assured us that no American fighter could reach Japan from their island bases. Yet there they were, dozens of them, flying as if they owned our sky. In that moment, I knew the war was truly lost. Below the American fighters, over 100 Boeing B-29 superfortresses assembled in their deadly formations, their aluminum skin glinting like scales on a school of silver fish. The rendezvous represented a triumph of navigation and planning that would have seemed like magic just 5 years earlier. The P-51s had flown 750 miles over featureless ocean, navigating by dead reckoning and basic radio compass, timing their arrival to within minutes of the bomber's schedule. What followed would demonstrate the vast technological gulf between two nations' approaches to air warfare. It would reveal why American industrial might had produced what many would call the perfect long-range fighter, and it would shatter the last Japanese illusions about their ability to defend the homeland. This is the story of that shocking, the story of how American engineering and industrial capacity created a weapon that made the impossible routine. It's the story of the P-51D Mustang and the men who flew it to victory, and the desperate Japanese pilots who faced an enemy they could not defeat, flying machines their nation could no longer match. The path to that shocking April morning began not in the Pacific, but in the skies over Europe, where the P-51 Mustang had already written its legend in the contrails above Germany. The aircraft that would ultimately appear over Tokyo had been forged in the desperate struggle against the Luftwaffe, refined by the brutal lessons of 3 years of air combat, and perfected through the marriage of American aerodynamic innovation and British engine technology. In 1940, with Britain standing alone against Nazi Germany, the Royal Air Force desperately needed fighters. North American Aviation, a relatively young company based in California, received a British purchasing commission request for a new fighter aircraft. The specification was demanding: high speed, long range, and heavily armed. More importantly, it needed to be in production within 120 days, an impossibly short timeline that reflected Britain's desperate situation. Edgar Schmid, North American's brilliant German-born chief engineer, had been studying fighter design for years. He understood that the future of air combat belonged to aircraft that could fly higher, faster, and farther than anything currently in service. Working alongside a team of talented engineers, Schmid designed an aircraft around a revolutionary concept: the laminar flow wing. Traditional aircraft wings created turbulent airflow almost immediately, generating drag that limited speed and range. Schmid's laminar flow wing maintained smooth airflow over a much greater percentage of the wing surface, delaying the transition to turbulence and reducing parasitic drag by an astonishing 35%. The mathematics were elegant and ruthless. Less drag meant higher speed. Less drag meant longer range. Less drag meant the aircraft could carry more fuel, more ammunition, more of everything that mattered. The prototype flew in October 1940, just 102 days after the contract was signed. It was an aerodynamic masterpiece, sleek and purposeful, with lines that looked fast even standing still. But it had a problem. The Allison V1710 engine produced adequate power at low altitude, but gasped for breath above 15,000 feet, exactly where modern air combat was fought. The British, with their characteristic engineering pragmatism, saw the solution immediately. They took several Mustangs back to England and installed Rolls-Royce Merlin engines, the same power plants that had powered Spitfires through the Battle of Britain. The transformation was miraculous. The Merlin-powered Mustang became a different aircraft entirely, one that could outperform anything in the sky. The Merlin engine was itself a marvel of engineering sophistication. Its two-stage, two-speed supercharger was the key to high-altitude performance. The first stage compressed thin air, cooled it through an intercooler to increase density, then fed it to the second stage for additional compression. This delivered oxygen-rich air to the cylinders at altitudes where other engines struggled to run at all. At 25,000 feet, where Japanese engines produced perhaps 60% of their rated power, the Merlin maintained nearly sea-level performance. Packard Motor Company in Detroit received a license to manufacture the Merlin in America, designating it the V1650. By 1943, the P-51B and C models with Packard Merlins were entering service in Europe. By 1944, the definitive P-51D variant had arrived, incorporating lessons learned from thousands of combat missions. The P-51D featured a revolutionary bubble cockpit that provided 360-degree visibility. Pilots could actually see behind them by turning their heads, a seemingly simple feature that saved countless lives in combat. The armament was standardized to 6.50 caliber M2 Browning machine guns, 3 in each wing, positioned to provide concentrated firepower without excessive wing loading. Each gun was fed by ammunition belts containing a mix of armor-piercing, incendiary, tracer, and ball rounds. The Packard V1650-7 engine delivered 1,695 horsepower at takeoff, rising to 1,720 horsepower with water methanol injection for emergency war power settings. This brutal force drove a 4-blade Hamilton standard propeller 11 feet 2 inches in diameter. The propeller could be heard from miles away, a distinctive buzzsaw sound that became the signature of American air power. The aircraft stretched 32 feet 3 inches from nose to tail, with a wingspan of 37 feet. Empty, it weighed 7,125 pounds. Fully loaded for combat with internal fuel, external drop tanks, ammunition, and pilot, it could exceed 12,000 pounds. Yet despite this weight, the Mustang could reach 440 miles per hour at 25,000 feet and climb to an operational ceiling of 41,900 feet. But the P-51D's true revolutionary capability lay in its range. With internal fuel alone, the Mustang could fly roughly 950 miles. Add two 110-gallon external drop tanks, and that range extended to an astonishing 1,650 miles. This was equivalent to flying from Los Angeles to Little Rock, Arkansas, entirely over water in a single-engine aircraft with no alternate landing sites except the ocean itself. By the end of 1944, 14 of the 15 fighter squadrons of the U.S. 8th Air Force in Europe flew Mustangs. They had broken the back of the Luftwaffe, making daylight strategic bombing of Germany possible for the first time. The P-51 had achieved what planners had thought impossible. Allowing unescorted bombers deep into enemy territory became possible because the Mustangs could go everywhere the bombers went, stay with them for hours, and fight their way home. Now, with victory in Europe assured, those Mustangs and their pilots would turn their attention to Japan, and they would achieve something even more remarkable than their European exploits. While American factories pumped out P-51 Mustangs at a rate that staggered imagination, one aircraft every hour at peak production, Japan struggled to produce its most advanced fighter in numbers that mattered. The Nakajima Ki-84 Hayate, codenamed Frank by Allied intelligence, represented Japan's desperate attempt to match American technological superiority with what resources remained to the embattled empire. The aircraft entered operational service in June 1944, too late and in too few numbers to affect the war's outcome. Named Gale, the fighter embodied Japan's considerable engineering talent applied under increasingly impossible circumstances. On paper, the Hayate appeared competitive, even superior in some respects to American fighters. The aircraft was powered by the Nakajima Ha-45 Homare, 18-cylinder radial engine, a complex piece of machinery that used direct fuel injection and a single-stage two-speed supercharger. With water methanol injection to aid the supercharger, the Homare produced a rated 2,000 horsepower at takeoff. Initial testing showed promise, with prototypes reaching 387 miles per hour in level flight. Later claims suggested speeds up to 427 miles per hour under ideal conditions with high-octane fuel and perfect engine tuning.
The Ki-84's armament packed devastating punch: 4 20mm Ho-5 cannons, 2 in the nose and 2 in the wings, giving it formidable firepower. Some variants carried 2 30mm Ho-155 cannons in place of the wing-mounted 20mm guns, weapons capable of destroying any American aircraft with a single well-placed hit. The aircraft could also carry bombs for ground attack missions, making it theoretically versatile. In maneuverability trials, the T-84 proved it could outclimb and outturn both the P-51 and the Republic P-47 Thunderbolt at certain altitudes and speeds. Japanese test pilots praised its handling characteristics, reporting that it combined the speed of the Ki-44 Tojo with the maneuverability of the legendary Zero. On paper, Japan had finally produced a world-class fighter. The reality told a different story, one written in poor-quality steel, inadequate training, and systemic collapse. By 1945, Japan's industrial infrastructure was disintegrating under the weight of American bombing, naval blockade, and simple exhaustion. The factories that produced Ki-84s operated under conditions that made quality control nearly impossible. Precision machinery wore out and could not be replaced. Skilled workers had been drafted into the military or killed in air raids. The high-grade steel and aluminum required for aircraft construction became increasingly unavailable, replaced by inferior substitutes that compromised structural integrity. The Homare engine, while theoretically powerful and advanced, suffered from chronic reliability problems that worsened as quality control collapsed. The engine required precise tolerances in its 18 cylinders, tolerances the Japanese factories under constant B-29 bombardment could no longer maintain. Cylinder barrels contained impurities that caused uneven wear. Piston rings failed prematurely. Bearings seized without warning. Many Ki-84s reached operational units with engines that would not start reliably, ran rough at all power settings, or failed catastrophically in flight. Pilots reported engines that produced only 1,200 to 1,400 horsepower instead of the rated 2,000, reducing performance to levels barely superior to the obsolete Ki-43 Oscar. Some engines lasted less than 50 hours before requiring complete overhaul, assuming spare parts existed for such work. The landing gear proved even more problematic. The main gear struts, designed to retract inward into the wings, required steel that had been properly heat-treated to achieve the necessary strength. Late-war Japanese steel, produced from inferior ore and processed in furnaces running on substitute fuels, often contained impurities that made proper hardening impossible. The result was landing gear that could collapse without warning during landing or even while taxiing, writing off aircraft that Japan could not afford to lose and killing pilots who had taken months to train. Progressive deterioration in quality control meant that pilots never knew how any individual aircraft would perform. Would the brakes work? Would the engine hold together at high power settings? Would they be able to climb high enough to intercept B-29s cruising at 30,000 feet? Each mission became a gamble not just against American fighters, but against their own equipment. The fuel situation alone revealed the strategic catastrophe facing Japan, a nation that had gone to war partly to secure oil resources. While American pilots flew with 100-octane aviation gasoline shipped from refineries in Texas and California, fuel specifically formulated for high-performance engines, Japanese pilots made do with whatever could be produced domestically or synthesized from coal and other sources. Late-war Japanese aviation fuel often tested at 87-octane or lower, sometimes as low as 80-octane, robbing engines of power and causing pre-ignition that destroyed cylinders, pistons, and valves. Pre-ignition occurred when fuel ignited before the spark plug fired, creating shock waves that could crack pistons or burn holes through cylinder heads within minutes. Pilots learned to listen for the telltale pinging sound that preceded catastrophic engine failure. Some desperate units attempted to supplement their meager fuel supplies with pine root oil extracted from tree stumps, requiring 200 stumps to produce 1 gallon of barely usable fuel, alcohol distilled from sweet potatoes, and even sake production byproducts. These substitutes further degraded engine performance and reliability. Pilots reported engines that barely started, ran rough at all settings, and often failed catastrophically in flight, leaving them to choose between bailing out over enemy territory or attempting a forced landing in unsuitable terrain. By April 1945, Japan had produced approximately 3,513 Ki-84s. This number, which should have represented a significant fighter force, was rendered nearly meaningless by reality. Many had been destroyed on the ground by B-29 raids and carrier strikes before they ever flew a combat mission. Others were lost in training accidents caused by poor quality control and inadequately trained pilots. Still more sat grounded for lack of spare parts, fuel, or qualified pilots to fly them. Of those that remained operational, perhaps half could be considered truly combat-ready at any given time. The rest suffered from various maladies: engines that wouldn't start, landing gear that couldn't be trusted, radios that didn't work, oxygen systems that failed above 20,000 feet, and countless other problems that reflected an industrial base in collapse. The mathematics were brutal and unavoidable. While North American aviation produced 15,000 P-51 Mustangs with consistent quality and interchangeable parts, Japan struggled to field a few hundred Ki-84s of wildly varying capability. The contest was decided before it began, not by courage or skill, but by industrial capacity and technological sophistication.
Iwo Jima had been Japanese territory until February 1945, when 36 days of brutal combat transformed it into an American possession. The tiny volcanic island, barely 8 square miles of black sand and sulfurous earth, sat 750 miles south of Tokyo. To most people, it looked like worthless real estate, a hellish landscape dominated by Mount Suribaki's extinct volcanic cone. But to military planners, Iwo Jima was the key that would unlock Tokyo's skies. The island provided exactly what the P-51 Mustang needed, a forward base within range of the Japanese home islands. Engineers of the 9th, 31st, and 133rd Naval Construction Battalions, the legendary Seabees, performed miracles on Iwo's volcanic soil. Working under sporadic Japanese artillery fire from holdouts in the island's extensive cave system, they carved 3 airfields from the black sand: North Field, Central Field, and South Field. By April 1945, these airfields supported multiple fighter groups. The 15th Fighter Group arrived on March 6th, flying their P-51Ds directly from Saipan. The 21st Fighter Group followed shortly after. Together, these units formed the 7th Fighter Command under Brigadier General Ernest M. Moore, a hard-driving officer who understood that the P-51's capabilities could fundamentally change the air war over Japan. Living conditions on Iwo Jima made the island seem like purgatory. The volcanic sand got into everything: food, water, engines, sleeping bags, weapons. It abraded moving parts and clogged air filters. The sulfurous fumes that rose from vents in the earth smelled like rotten eggs and caused respiratory problems.
Fresh water had to be shipped in or distilled from seawater. Fresh food was a distant memory. The men subsisted on sea rations, Spam, powdered eggs, and coffee strong enough to strip paint. The tents that housed the pilots and ground crews sat in rows on the black sand, offering minimal protection from the sun's brutal heat or the island's surprisingly cold nights. Pilots slept on cots that sand fleas considered prime real estate. Showers were makeshift affairs, using water heated by the sun in metal drums. Toilets were basically trenches covered by wooden seats. Mail call was the high point of any week, a connection to a world that seemed increasingly distant and unreal. Yet despite these privations, morale remained surprisingly high. The men of the 7th Fighter Command understood they were making history. They were about to do something no fighter pilots had ever done before: escort heavy bombers on missions of 1,500 miles round trip, most of it over open ocean. The planning for the first escort mission to Tokyo consumed weeks of intensive work. Meteorologists studied weather patterns over the Pacific, looking for days when frontal systems wouldn't make the crossing impossible. Navigation experts calculated courses that would account for winds aloft, magnetic variation, and fuel consumption at various altitudes. Intelligence officers compiled target folders with photographs of Japanese airfields, anti-aircraft positions, and likely interception points. Maintenance crews worked around the clock to ensure maximum aircraft availability. Every P-51D received intensive inspection. Engines were checked and rechecked, fuel systems were purged of any contamination, guns were bore-sighted until they fired true. Every aircraft needed to be perfect. A mechanical failure over the Pacific meant almost certain death. The Mustangs would carry 2 110-gallon drop tanks hung beneath the wings. These teardrop-shaped tanks, made of pressed paper impregnated with synthetic resin to save aluminum, would extend the P-51's range from roughly 950 miles to over 1,600 miles. The mathematics were simple but unforgiving. Internal fuel capacity, 269 gallons. Drop tank fuel, 220 gallons. Total, 489 gallons of 100-octane fuel. At economical cruise settings, burning approximately 65 gallons per hour, this gave roughly 7.5 hours of flight time. The mission profile called for takeoff from Iwo Jima, climb to 25,000 feet while crossing 750 miles of ocean, rendezvous with B-29s, provide escort for 2 to 3 hours including combat, then return 750 miles home. The margins were thin, very thin. There would be no second chances, no alternate destinations, no room for error. Rescue submarines, designated lifeguard stations, positioned themselves along the route. These fleet submarines, among the Navy's most valuable assets, would patrol specific locations, ready to rescue any pilot forced to ditch. It was a remarkable commitment of resources, putting multi-million-dollar submarines at risk to save single pilots, but it reflected the value America placed on trained aircrew. PBI Catalina flying boats, nicknamed Dumbos, would also patrol the route when possible, ready to land on the open ocean to retrieve downed pilots. Each P-51 pilot carried survival equipment in case of ditching: a one-man life raft in the seat cushion, dye marker to color the water for search aircraft, an emergency radio beacon, emergency rations, water purification tablets, and a .45 caliber pistol with ammunition. As April 7th approached, tension on Iwo Jima built palpably. The pilots of the 15th and 21st Fighter Groups understood they were about to attempt something unprecedented in aviation history. Weather scouts reported favorable conditions. The mission was on. At 0530 hours on April 7, 1945, pilots gathered for the final briefing in a Quonset hut at North Field. Maps covered the walls, showing the route, navigation checkpoints, and the rendezvous point with the B-29s. Intelligence officers pointed out Japanese airfields and likely interception points. Weather officers described conditions aloft: winds from the northwest at 20 to 30 knots at altitude, scattered clouds over the home islands, good visibility. "Gentlemen," General Moore addressed the assembled pilots, "you're about to make history. When you appear over Tokyo, you'll be the first land-based Army fighters to reach the Japanese capital. The Japanese military has assured their people this is impossible. Show them they're wrong. Good hunting."
At 6:30 a.m., engines began to fire up across the 3 airfields. The distinctive sound of Packard Merlin engines filled the air, 7,200 horsepower per aircraft, multiplied by nearly 100 aircraft, a symphony of mechanical power that represented American industrial might made audible.
Major James B. Tapp, leading the 45th Fighter Squadron, ran through his checklist with practiced precision. Fuel selector on main tank, mixture rich, propeller full forward, magnetos checked, oil pressure rising, coolant temperature coming up. Every gauge had to be in the green. Any indication of problems meant aborting, and no pilot wanted to abort on a mission this historic. At 6:50 a.m., the first flights began taking off. The heavily laden Mustangs, each carrying nearly 500 gallons of fuel plus ammunition, used most of the runway's length before lifting into the early morning sky. Pilots nursed their aircraft into the air, careful not to overload the wings during the climb-out. The drop tanks, while necessary, added drag and weight that made the aircraft handle sluggishly until enough fuel had been burned to lighten the load. The groups formed up over Iwo Jima, circling Mount Suribachi like silver hawks, then turned north toward Tokyo. Behind them, the island receded into the distance until only Suribachi's peak remained visible, then that too vanished below the horizon. Ahead lay 750 miles of empty Pacific Ocean, and at the end of that impossible distance, the enemy capital, where over 100 Japanese fighters waited. The pilots settled in for the long flight north. Beneath them, the ocean stretched endlessly, featureless, hypnotic. The ocean was a blue void broken only by occasional whitecaps. There were no landmarks, no points of reference, nothing but water extending to the horizon in all directions. Navigation became an act of faith, trust in compass headings calculated before takeoff, trust in dead reckoning, trust that the winds aloft matched forecasts. Every pilot understood what a mechanical failure would mean out here. They flew single-engine aircraft over an ocean so vast that if they went down, they might drift for weeks without seeing another vessel. The lifeguard submarines helped, but they covered only small portions of the route. Survival depended on the Packard Merlin engines running smoothly, on fuel systems functioning perfectly, on nothing going wrong for 7.5 hours. As they climbed to altitude, pilots switched fuel tanks at regular intervals, burning the external tanks first to conserve internal fuel for the combat and return flight. The drop tanks would be jettisoned when empty or when combat was imminent, whichever came first. The external tanks limited the P-51's performance. Keeping them during combat would be suicide. At 25,000 feet, the air temperature dropped to 20 degrees below 0 Fahrenheit. Pilots wore heavy flying suits, but cold still seeped in around the edges, numbing fingers and toes. The oxygen masks, necessary above 15,000 feet, felt confining and claustrophobic. Breathing through the mask for hours caused some pilots to develop headaches or feel slightly hypoxic despite the oxygen flow. The physical strain was enormous. Pilots sat strapped into uncomfortable cockpits, unable to stand or stretch, unable to move more than a few inches in any direction. The parachute harness cut into shoulders, the dinghy packed into the seat cushion, pressed against buttocks until everything went numb. Relief tubes allowed urination, but they often froze at altitude, forcing pilots to either hold it or wet themselves. The psychological strain matched the physical. Every pilot knew that one navigation error, one miscalculation of fuel consumption, one unexpected headwind could mean running out of gas over the ocean. They monitored their fuel gauges obsessively, comparing consumption against planned rates, calculating and recalculating whether they had enough to make it home. After 3 hours of flying over featureless ocean, a faint dark line appeared on the northern horizon. Land. The Japanese home islands. The pilots had navigated perfectly, hitting their landfall almost exactly where planned. Within minutes, the distinctive cone of Mount Fuji rose ahead, its snow-capped peak unmistakable even from 50 miles away. At 0700 a.m., the P-51s reached their rendezvous point with the B-29 superfortresses of the 73rd Bomb Wing. 103 of the massive bombers circled in a grand assembly, their aluminum skin glinting in the morning sun like a school of giant silver fish swimming through the sky. Captain Art Bridge of the 45th Fighter Squadron would later recall, "It was a real spectacle. The 29s were just finishing their assembly in a grand circle as we arrived. The sun glinted off their aluminum skin, and they looked like a school of giant silver fish swimming through the sky." The bombers were magnificent machines in their own right. each one a four-engine giant with pressurized crew compartments and remote-controlled gun turrets. Each carried tons of incendiary bombs destined for Japanese industrial targets. But despite their size and defensive armament, they remained vulnerable to determined fighter attack. The P-51s would provide the protection that made daylight precision bombing possible. As the formation assembled and turned toward Tokyo, Japanese radar stations detected them. Air raid sirens wailed across the capital. Ground controllers began vectoring interceptors toward the incoming threat. In airfields around Tokyo, pilots scrambled to their aircraft, not yet knowing that history was about to demonstrate the meaning of technological obsolescence. The Japanese fighter pilots climbing to meet the American formation that morning included some of the Imperial military's remaining experienced airmen, veterans who had survived the grinding attrition of 3 years of brutal air combat. But increasingly, they flew alongside teenagers with minimal training, boys who had been in high school just months before, thrust into combat with barely enough flight time to take off and land safely.
Flight Sergeant Isamu Totonimitsu, flying his K-84 with the 56th Sentai, was one of the experienced pilots. He had survived the Battle of the Philippines, where American carrier fighters had decimated Japanese air forces. He had flown over Okinawa, where the slaughter had been even worse. He understood what was coming, even if younger pilots around him didn't. When the scramble order came, he felt the familiar knot of fear in his stomach, but also resignation. This was his duty. He would fly, he would fight, and probably, like so many before him, he would die. As Totonimitsu climbed through 15,000 feet, his K-84's engine began showing the symptoms that had become all too familiar. The Homare radio coughed and missed, running rough as the fuel mixture went rich. Black smoke streamed from the exhaust, visible evidence that the engine was burning oil along with gasoline. The aircraft shook violently, making his instruments blur and his vision swim. At 20,000 feet, the symptoms worsened. The single-stage supercharger, lacking the intercooling and two-stage compression of American engines, struggled to maintain power. Totonimitsu's climb rate dropped from 3,000 feet per minute to barely 1,000. He pushed the throttle forward, but the engine protested, the cylinder head temperature gauge climbing into the red zone that signaled imminent damage. Around him, other K-84s and older fighters struggled with similar problems. Some pilots turned back, their engines failing completely or running so roughly that continuing was suicide. Others pressed on, knowing that every fighter that turned back meant fewer defenders against the American bombers that were systematically destroying Japan's cities and industrial capacity. At 25,000 feet, Totonimitsu leveled off, his engine barely maintaining power, running hot and rough. He looked around for his wingman, a 19-year-old named Tanaka, who had less than 40 hours of flight time. Tanaka's aircraft was nowhere to be seen. Perhaps his engine had failed. Perhaps he had become disoriented and lost the formation. Perhaps he had simply panicked and fled. Totonimitsu would never know. Then, through the clear morning air, he saw them. The American formation filled the sky ahead like a silver cloud. Over 100 B-29 superfortresses, each one larger than any bomber in the Japanese inventory, flew in tight formations that spoke of training and discipline. Around them, above them, weaving through them, were the fighters. P-51 Mustangs, dozens of them. Silver aircraft with distinctive bubble canopies and invasion stripes painted on their wings. Land-based fighters, single-engine fighters that had somehow flown 750 miles across the Pacific Ocean to appear over Tokyo like avenging angels. When I saw the Mustangs with my own eyes, I thought I was dreaming. It was impossible. Our commanders had assured us that no American fighter could reach Japan from their island bases. Yet there they were, dozens of them, flying as if they owned our sky. In that moment, I knew the war was truly lost. The psychological impact was immediate and devastating. Every Japanese pilot had been told the divine wind would protect the homeland. They had been assured that American fighters lacked the range to reach Japan from island bases. Naval fighters from carriers could reach the home islands, yes,
but carriers could be sunk. Land-based fighters were permanent, inexhaustible, impossible to destroy. And now they were here, over Mount Fuji, over Tokyo, over the Emperor's Palace itself. Major James B. Tapp, leading elements of the 45th Fighter Squadron at the head of the American formation, saw the Japanese fighters climbing to meet them. Through his gun sight, he counted them: 30, 40, 50 aircraft, a mix of types. Some were K-84s, Japan's best. Others were older K-43 Oscars, K-44 Tojos, even a few Zero fighters that looked like museum pieces compared to modern fighters. They came at us in the traditional three-plane Shotai formation, but their coordination was poor. The flight leader would commit to an attack, but his wingmen often failed to follow through. They seemed hesitant, perhaps low on fuel or ammunition, or simply inexperienced. We dove through them with a 100-mile-per-hour speed advantage, fired quick bursts, and Zoom climbed back to altitude before they could react. The first pass was devastating for the Japanese. American pilots, each with hundreds of hours of gunnery training, opened fire at ranges of 400 to 600 yards. The 6.5 caliber machine guns in each P-51 could deliver 80 rounds per second of concentrated firepower. With nearly 2,000 rounds of ammunition per aircraft, American pilots could afford to take ranging shots, to fire sustained bursts, to engage multiple targets. Japanese pilots, flying aircraft with perhaps 400 total rounds for their cannons and machine guns combined, had to make every shot count. Most had received minimal gunnery training, perhaps firing 100 rounds total before being sent to combat. They struggled with the complex ballistics of mixed armament, their 20mm cannons following different trajectories than their 7.7mm machine guns, making accurate shooting nearly impossible beyond close range. The Japanese came in fast and determined, accepting that many would die to reach the B-29s. Some attacked in traditional diving passes. Others attempted head-on runs, trying to break up the American formations. A few attempted to ram, a desperate tactic that reflected Japan's growing fatalism. One K-84 pilot, perhaps more skilled or simply luckier than most, managed to evade the initial American attacks and dove toward a B-29 on the formation's edge. His 20mm cannons opened fire at 300 yards. Shells walked up the bomber's fuselage, shattering plexiglass and punching through aluminum skin. The B-29 staggered but held formation, its gunners returning fire with their .5 caliber defensive armament.
Before the Japanese pilot could press his attack, 3 P-51s were on him. Tapp's wingmen, flying as trained, moved to protect the bomber. Their combined firepower, 18.50 caliber machine guns, found the K-84 within seconds. Armor-piercing incendiary rounds punched through the radial engine, smashed the cockpit canopy, and set the aircraft's fuel tanks ablaze. The K-84 tumbled from the sky, trailing fire and black smoke, its pilot dead or unconscious, already becoming a statistic. The engagement lasted perhaps 15 minutes of chaos and violence. American pilots, with their superior training and far better aircraft, methodically picked apart the Japanese formation. The P-51s could dive faster than the Japanese could follow, climb back to altitude before interception became possible, and repeat the process endlessly. Their performance differential was particularly evident above 20,000 feet, exactly where most combat took place. At these altitudes, the Merlin engine's two-stage supercharger maintained sea-level power, while Japanese engines gasped for breath. At 30,000 feet, a K-84 could barely maintain 350 miles per hour, struggling to stay airborne. A P-51D at the same altitude could still achieve 420 miles per hour, giving American pilots an overwhelming speed advantage. Lieutenant Jerry Yellen of the 78th Fighter Squadron, who would later fly the last combat mission of the war, described a typical engagement. We'd spot them climbing up to meet us, leaving dark exhaust trails as they firewalled their throttles, but by 25,000 feet they were wallowing like fish out of water. Their engines were smoking, probably running too rich because their superchargers couldn't provide enough air.
We dived through their formation with our 50s blazing, the tracers looking like laser beams, and they simply couldn't match our speed in the dive or our zoom climb afterward. Our Merlin would sing as we pulled up, G-forces crushing us into our seats, while their radials would cough and sputter, struggling to maintain power. Totani Misu, his Ki-84's engine overheating badly and losing power with each passing minute, attempted one desperate attack. He dove toward a straggling B-29, but two P-51s intercepted him. He tried to turn with them, and for a moment, the Ki-84's superior maneuverability allowed him to evade their initial burst. But turning bled energy, and energy was life in air combat. As his speed dropped, the Mustangs simply extended away, climbed above him, and dove again with even greater speed advantage. This time, he saw the tracer rounds coming, bright lines of fire that seemed to move slowly, then suddenly accelerated. He yanked the stick, desperate to evade, but his aircraft responded sluggishly. One round, then dozens, hammered his Ki-84. He felt impacts as rounds punched through his wings, heard the sickening sound of metal being shredded. His canopy shattered, showering him with plexiglass fragments. Wind shrieked through the cockpit. His engine was hit. The Homade coughed once, twice, then seized completely with a horrible grinding sound. Oil sprayed across his windshield, hot and black. Fire erupted from the cowling. Totani Misu had perhaps 10 seconds to decide, ride the dying aircraft down or bail out. He chose life, releasing the canopy latch that had been damaged by the American fire, struggling against the slipstream to climb out onto the wing. At 18,000 feet, minus 20 degrees, with American fighters swarming around him, he jumped. The slipstream tore at him. He tumbled end over end, disoriented, unable to tell up from down. At 10,000 feet, he pulled the ripcord. The parachute deployed with a violent jerk that nearly dislocated his shoulders, but it opened fully. He hung suspended in the silk, watching his Ki-84 spiral down, trailing smoke until it impacted in a rice paddy below, exploding in a ball of orange flame. Above, the air battle continued. More Japanese fighters fell from the sky, trailing smoke and fire. Some pilots managed to bail out. More rode their aircraft down, either dead, unconscious, or unable to abandon their machines. The mathematics were brutal. For every American loss, and there would be 2 P-51s lost this day, the Japanese lost 10 to 15 fighters. By the time the B-29s completed their bomb run and turned south for home, the sky over Tokyo told the story of American superiority. Dozens of smoke trails marked where Japanese fighters had fallen. Oil slicks in Tokyo Bay showed where some had crashed into water. Wreckage burned in rice paddies, on city streets, across military installations. The American formation reformed and headed south, the P-51s still weaving protectively around their charges. Japanese interceptors, those that remained, made a few half-hearted attacks, but were driven off easily. Most Japanese pilots, seeing the carnage and understanding the futility of further combat, broke off and headed for their bases, if their fuel-starved engines would take them that far. Major Tapp looked at his fuel gauge as they crossed the coast heading south. He had burned more fuel in combat than planned. Maneuvering, diving, climbing, burned fuel at prodigious rates. But he still had enough. The long flight home would be tight, but manageable. He thought about the Japanese pilots they had just defeated, many of them brave men flying inadequate aircraft with insufficient training and no hope of victory. War was cruel. Technology made it crueler still. As the P-51s and B-29s droned south toward Iwo Jima, Tokyo's skies slowly cleared. Fire trucks responded to crash sites, medical teams searched for survivors, and in command headquarters across the city, Japanese military leaders faced the unthinkable reality that their airspace, the sacred homeland itself, was no longer defensible. When the Mustangs landed back at Iwo Jima that evening, after more than 7 hours in the air, the ground crews counted 26 confirmed Japanese aircraft destroyed, 1 probable and 5 damaged. 2 P-51s had been lost, 1 to enemy fire, 1 to mechanical failure over the ocean. The pilot who went down to mechanical failure was never found despite submarine search efforts. The 13-to-1 kill ratio would only improve in subsequent missions. Within weeks, ratios of 20-to-1 or even 30-to-1 would become common, reflecting not just American technological superiority, but Japanese desperation and the complete collapse of their pilot training programs. That evening, as pilots gathered in mess tents eating Spam and powdered eggs, they knew they had made history. They had done what everyone said was impossible. They had flown single-engine fighters 1,500 miles round-trip to escort bombers over the enemy capital, and they had crushed the defending Japanese fighters with an ease that was almost anticlimactic. In Tokyo, Flight Sergeant Totanamizu landed in a farmer's field, his parachute draped over bamboo stalks. Farmers helped him out of his harness, bowing respectfully to the fighter pilot who had defended their homeland. He tried to explain what he had seen. The silver fighters that had come from impossible distances, the overwhelming American numbers, the technological gap that made courage irrelevant, but words failed him. That night, in a military hospital where doctors treated his minor injuries from bailing out, Totanamizu wrote in his diary, "The appearance of American fighters over Tokyo has shattered our confidence completely. We were told the B-29s were vulnerable without escort, that their fighters could never reach so far. Now we see Mustangs over the palace itself, strafing our airfields in broad daylight, shooting down our best pilots as if they were beginners. How can we defend the emperor when the enemy's fighters roam freely over the sacred homeland? The sight of those Mustangs, so confident, so numerous, tells us what our leaders will not. The war is lost, and we are simply waiting to die." The next mission would launch in 3 days, and the day after that, and the day after that. The impossible had become routine. The Mustangs would return again and again, each mission further demonstrating Japan's inability to defend itself, each mission bringing the empire closer to inevitable defeat. The shock of April 7th would never fully wear off. Even decades later, Japanese survivors would speak in hushed tones about the day American fighters appeared over Mount Fuji, the day the divine wind died, the day they knew with absolute certainty that the war was lost. The missions continued with methodical inevitability. April 12th, 91 P-51s escorting B-29s to Tokyo. April 16th, 108 Mustangs ranging ahead of the bomber stream, sweeping Japanese fighters from the sky. May 23rd, a massive raid with over 150 P-51s demonstrating complete American air superiority. Each mission wrote the same brutal equation: American industrial capacity multiplied by technological superiority equals inevitable victory. But victory came with its own costs and complications. On June 1st, 1945, a day the Mustang pilots would come to call Black Friday, weather demonstrated that even American technology had limits. Approximately 150 P-51s launched that morning for Osaka, Japan's second-largest city. Weather forecasts predicted scattered clouds, manageable conditions for the long over-water flight. The forecasts were wrong. A massive frontal system, missed by reconnaissance or simply developing faster than predicted, sat directly across their route. Towering cumulus clouds extended from sea level to 40,000 feet, filled with violent turbulence, icing conditions, and zero visibility. Lieutenant Bob DeHaven, leading a flight of 4 Mustangs, described entering the front. "One moment we were in clear air. The next we were in solid clouds so thick I couldn't see my own wingtips. The turbulence was like nothing I had experienced. The aircraft pitched and rolled violently. My artificial horizon tumbled uselessly, the gyroscope unable to cope with the motion. I was flying blind, on partial panel, trying to maintain altitude and heading, while being thrown around the cockpit hard enough to bruise despite my safety harness. In instrument meteorological conditions, formation flying becomes nearly impossible. Pilots lose visual reference and must rely entirely on their instruments, something many hadn't trained for adequately. Without visual cues, maintaining formation spacing is impossible. Aircraft scatter, each pilot fighting alone to keep their machine upright and pointed in roughly the right direction. Static electricity built up on metal surfaces, creating St. Elmo's fire, eerie blue flames that danced along wing edges and propeller tips. Compasses spun uselessly, their magnetic fields disrupted by the electrical activity. Radio reception became garbled with static. Pilots found themselves truly alone, surrounded by clouds that could contain other aircraft, mountainsides, or nothing at all. Ice accumulated on wings, propellers, and windscreens, changing aerodynamic properties and adding dangerous weight. Carburetors iced over, causing engines to cough and sputter. Some pilots applied carburetor heat, but that reduced power at a time when maximum performance was needed just to maintain altitude in the turbulent air. 24 P-51s were lost in minutes, not to Japanese fighters or anti-aircraft fire, but to weather. Some pilots became disoriented and flew into the ocean, unable to determine which way was up. Others collided with wingmen they couldn't see in the clouds. A few ran out of fuel while trying to find clear air, their engines falling silent as tanks ran dry, leaving them no choice but to bail out over the ocean, with minimal chance of rescue.
3 more aircraft made it back to Iwo Jima, but crashed attempting to land in severe crosswinds and low visibility. The total? 27 aircraft lost, 24 pilots dead, on a mission that never even engaged the enemy. It was the worst single-day loss the P-51 units would suffer in the Pacific Theater. Black Friday taught brutal lessons about the limits of very long-range operations. Weather over the Pacific could change rapidly and unpredictably. Even the best aircraft and most skilled pilots could be overwhelmed by meteorological forces. The missions were inherently dangerous, pushing men and machines to absolute limits even without enemy action. But the missions continued. The strategic necessity of striking Japan outweighed the risks. New weather reconnaissance procedures were implemented. Pilots received additional instrument training. Alternate routes were planned around predicted frontal systems. The losses on June 1st were grievous, but they didn't stop the steady drumbeat of American air attacks on the Japanese homeland. By July 1945, the pattern was well established. P-51s ranged freely over Japan, strafing airfields, attacking trains and shipping, shooting down any Japanese aircraft foolish enough to rise and challenge them. Japanese fighter opposition had essentially collapsed. Fuel shortages grounded most aircraft. The pilots who remained had minimal training and no hope of victory. Captain Yoshio Yoshida, flying one of the few remaining operational K-84s with the 47th Sentai, wrote in his diary, "We have perhaps 10 aircraft in flyable condition. Of these, maybe 5 have enough fuel for one sortie. We have ammunition for our guns, but no pilots trained to use it effectively. The Americans appear over our airfield daily, destroying aircraft on the ground, shooting up our fuel trucks, killing mechanics and ground crew. We hide our remaining fighters under camouflage nets and pray the Americans don't spot them. When we do manage to get airborne, we're outnumbered 20-1 by Mustangs that are faster, better armed, and flown by pilots who have hundreds of hours of training. I have lost 12 wingmen since April. 12 boys, none over 20 years old, all dead trying to defend a homeland we no longer have the means to protect. The war is lost. We are just prolonging the inevitable, buying time measured in days until the Americans land and it truly ends." The industrial statistics told the story more clearly than any combat report. By August 1945, North American aviation had produced 15,586 P-51s of all variants. The D model alone accounted for 8,156 aircraft, more than Japan's total production of all fighter types in the last 2 years of the war combined. At peak production, a new Mustang rolled off the assembly line every hour, 24 aircraft per day, more than 150 per week. Behind each aircraft stood an industrial infrastructure that Japan could not match. Packard Motor Company in Detroit produced Merlin engines at a rate of hundreds per month. Factories across America stamped out aluminum airframes, manufactured instruments, produced ammunition, refined aviation fuel. Liberty ships carried this material across the Pacific at a rate of 3 ships launched per day at peak production. Japan, meanwhile, was attempting to extract aviation fuel from pine roots. Industrial production had collapsed under American bombing and naval blockade. The few K-84s still being produced varied wildly in quality, with some aircraft barely flyable due to poor materials and workmanship. Training new pilots had become nearly impossible, with fuel rationed so severely that student pilots received perhaps 10 hours of flight instruction before being sent to operational units.
The training disparity was even starker than the industrial gap. American pilots arriving in the Pacific Theater typically had 400 to 600 hours of flight time, including 100 hours in the P-51 specifically. They had fired thousands of rounds in gunnery training, practiced formation flying until it was second nature, learned instrument navigation, and trained extensively in combat tactics. Japanese pilots in 1945 often had less than 50 hours total flight time, sometimes as little as 30 hours. They had minimal gunnery practice due to ammunition shortages. Many had never fired their guns until their first combat mission. They learned combat tactics from manuals written by pilots who were now dead. They flew aircraft they didn't trust with fuel they knew was inadequate. The psychological impact of this disparity was devastating. Japanese pilots went into combat knowing they were outmatched, flying inferior aircraft, inadequately trained, against an enemy that seemed to have unlimited numbers and resources. American pilots, conversely, flew with confidence born of superior technology, extensive training, and the knowledge that if they went down, rescue forces would search for them. The submarine lifeguard stations positioned along the route from Iwo Jima to Tokyo saved dozens of American pilots who were forced to ditch due to mechanical problems or battle damage. These fleet submarines, among the Navy's most valuable assets, were positioned specifically to rescue downed airmen, a remarkable commitment of resources that reflected how highly America valued trained pilots. Japanese pilots had no such safety net. If forced to bail out over water, they faced almost certain death from drowning or hypothermia. Their life rafts, if they had them at all, often leaked. Their survival rations had usually been consumed on the ground during food shortages. They flew knowing that ditching meant death, and still they flew because duty demanded it, and because some vestige of honor remained even in the face of inevitable defeat. Lieutenant Colonel John R. Morgan of the 457th Fighter Squadron conducted several photo reconnaissance missions over Japan in specially modified P-51D equipped with cameras in place of guns. His reports provided stark evidence of Japanese aviation collapse. We'd fly over airfields that intelligence said housed hundreds of aircraft. We'd find maybe a dozen flyable planes. The rest were derelicts, no engines, no propellers, some just aluminum shells cannibalized for parts. They'd push wrecks around between our reconnaissance flights to make it look like they had more operational aircraft, but we could tell the difference between a real airplane and a hulk. Some airfields had wooden mock-ups, complete with painted markings, trying to draw our attacks away from real planes hidden under camouflage. It was pathetic in a way. These people were desperate, out of fuel, out of parts, out of pilots, but they kept up the pretense of defense. By August 1945, Japan had perhaps 200,000 gallons of aviation fuel remaining in the home islands, enough for maybe one major operation or several weeks of minimal defensive patrols. The empire that had gone to war partly to secure oil resources was now reduced to extracting unusable fuel from tree stumps and converting training aircraft to kamikaze weapons because conventional operations had become impossible.
The logistics supporting American operations from Iwo Jima were staggering. Each mission consumed approximately 60,000 gallons of 100-octane fuel for one fighter group alone. Ships arrived at Iwo Jima daily, unloading fuel, ammunition, spare parts, food, mail, and thousands of other items needed to maintain modern air operations. Ground crews could perform engine changes in 4 hours using mobile cranes and standardized procedures. Battle damage that would ground a Japanese fighter for weeks could be repaired overnight, using prefabricated parts flown in from the States. The maintenance statistics were telling. P-51Ds at Iwo Jima maintained operational rates above 80% despite harsh conditions, volcanic dust that infiltrated everything, salt air that corroded aluminum, and minimal facilities that meant most work was done outdoors. Ki-84s, even when fuel and ammunition were available, suffered serviceability rates below 40%, sometimes as low as 20%. The complex Homare engine required specialized tools that often didn't exist, trained technicians who were mostly dead or drafted, and spare parts that had to be hand-fitted because manufacturing tolerances were so poor. August 1945 brought the war's endgame with brutal finality. On August 6th, the B-29 Enola Gay dropped an atomic bomb on Hiroshima.
On August 9th, another atomic bomb destroyed Nagasaki. These apocalyptic weapons, delivered by B-29s flying without escort because escort was no longer necessary, killed hundreds of thousands of people and demonstrated a new level of destructive capability that made continued resistance pointless. But even as Japan's government debated surrender, air operations continued. On August 10th, P-51s from the 15th and 506 fighter groups engaged Japanese fighters near Tokyo in what would be one of the last air battles of World War II. 7 Japanese aircraft were claimed destroyed. By this point, Japanese resistance had become almost token. Most fighters were grounded for lack of fuel. Those that did fly were often piloted by teenagers with minimal training, boys who had been in high school months before. Lieutenant Jerry Yellen of the 78th Fighter Squadron prepared for what would become the war's last combat mission on the morning of August 14, 1945, August 15th in Japan due to the international dateline. Yellen and his wingman, 19-year-old Second Lieutenant Philip Schlamberg, took off from Iwo Jima with orders to strafe airfields near Nagoya. The mission had been planned before word of Japan's surrender reached the field. The code word Utah that would have recalled us never reached our radios, or perhaps we missed it in the static. We flew to Japan, found our targets, and attacked as ordered. They strafed their assigned targets: aircraft dispersal areas, fuel storage tanks, hangars. Japanese anti-aircraft fire was surprisingly intense despite the Emperor having already recorded his surrender broadcast that would be transmitted at noon. Yellen and Schlamberg made their attack runs, their .50 caliber machine guns ripping up ground installations, then pulled up and headed for a cloud bank to escape the flak. "We flew into the clouds together," Yellen remembered. "When I came out the other side, Phil was gone. I called for him on the radio. Nothing. I circled the area for as long as my fuel allowed, looking for a parachute, looking for any sign. Nothing. I had to turn for home or I wouldn't make it back myself." Second Lieutenant Philip Schlamberg had been shot down by anti-aircraft fire, becoming the last American combat death of World War II. He was just 19 years old. His P-51D crashed in a rice paddy near Nagoya, the wreckage not discovered until decades later when Japanese researchers located the site and identified it through serial numbers. Hours after Schlamberg died, Emperor Hirohito's surrender broadcast played across Japan. His voice, never before heard by most Japanese citizens, announced that the empire would accept the Potsdam Declaration and surrender unconditionally. The war that had begun with Pearl Harbor and consumed millions of lives across the Pacific was over. But for the P-51 Mustang pilots on Iwo Jima, the sudden end brought relief mixed with profound emptiness. They had trained for war, flown combat missions that pushed them to their absolute limits, lost friends and squadron mates. Now, suddenly, it was over. No more missions, no more combat. They had survived. Between April 7th and August 15th, 1945, Iwo Jima's P-51 Mustangs were credited with 206 Japanese aircraft destroyed in air-to-air combat, representing 75% of all Pacific P-51 aerial victories. The actual number was probably higher, as many Japanese aircraft shot down over their homeland were never confirmed, their wreckage lost in forests or urban areas. But aerial victories were almost beside the point by the war's end. The P-51's true strategic impact lay in what it made possible: daylight precision bombing of Japanese industrial targets with minimal losses. B-29s could now bomb in daylight, with fighter escort, achieving accuracy impossible during night raids. Japanese industrial production, already crippled by material shortages and earlier bombing campaigns, ground to a complete halt under precision daylight attacks. The psychological effect was equally important. Japanese civilians could see American fighters strafing airfields in broad daylight, shooting up trains, attacking shipping in Tokyo Bay. The myth of the divine wind, the kamikaze that would protect Japan as it had against Mongol invasions in the 13th century, was shattered when American fighters flew over the imperial palace itself without opposition.
The contrast between American and Japanese fighter aircraft that played out in the skies over Tokyo represented more than just technical specifications or engineering choices. It reflected fundamentally different approaches to industrial warfare and revealed truths about modern conflict that transcended individual courage or tactical skill. The P-51D Mustang embodied American industrial philosophy applied to warfare: mass production with rigorous quality control, standardization across manufacturers, continuous improvement based on combat feedback. Every P-51D that rolled off the production line was essentially identical, with interchangeable parts and predictable performance. A pilot could climb into any Mustang and know exactly how it would fly, exactly where every switch and instrument would be located, exactly what performance to expect. This standardization extended throughout the supply chain. Packard-built Merlin engines were interchangeable with British-built units. Replacement parts from different manufacturers fit perfectly. Training manuals, technical orders, and maintenance procedures were standardized across all units. When an engine needed changing, ground crews could unbolt the old unit, bolt in a new one, and have the aircraft flying again in 4 hours, sometimes less. The K-84 Hayate, despite being Japan's most advanced fighter aircraft, showed the limitations of an industrial base under severe stress. Even aircraft from the same factory in the same production batch showed wild variations in performance. One K-84 might be capable of 400 miles per hour, while another struggled to exceed 350 due to manufacturing inconsistencies. Landing gear that worked perfectly on one aircraft would collapse on another from the same batch due to poor quality heat treatment of steel. Japanese maintenance crews had to hand-fit replacement parts because manufacturing tolerances were so inconsistent. An engine from one batch might not properly fit an airframe from another batch. Tools were improvised from whatever materials could be scrounged. Technical manuals, when they existed at all, often didn't match actual aircraft configurations because modifications were made during production without documentation. The pilot experience in each aircraft told the story in human terms. P-51D pilots sat in ergonomically designed cockpits where years of combat experience had refined every detail. The bubble canopy provided 360-degree visibility. Seat position and rudder pedals adjusted for pilots of different sizes. Controls were positioned to minimize fatigue during long missions. The instrument panel was logically arranged with the most critical gauges: airspeed, altitude, engine instruments, directly in the pilot's line of sight. Climate control, primitive by modern standards but revolutionary for 1945, used engine coolant to heat the cockpit at altitude. This seems trivial until you've spent 8 hours at 25,000 feet where outside air temperature is 20 below zero. American pilots could maintain comfort and alertness throughout marathon missions. They wore anti-G suits that prevented blackouts during high-G maneuvers by using air pressure to squeeze blood back to the brain. Their oxygen systems functioned reliably with automatic flow regulation. They had working radios for communication and navigation aids. K-84 pilots often flew without functioning radios, their vacuum tube sets consuming precious battery power and rarely working properly anyway. They had no anti-G suits, limiting their ability to match American aggressive maneuvering without blacking out. Oxygen systems frequently failed above 20,000 feet, leading to hypoxia that clouded judgment and slowed reactions. Cockpit visibility was compromised by structural members and the fuel tank position behind the pilot's head. The armament comparison reveals how combat experience shaped design choices. The P-51D's 6.50 caliber machine guns, while seemingly less impressive than the K-84's mixed cannon armament, offered crucial advantages. American guns were extraordinarily reliable, with stoppage rates below 1% when properly maintained. They carried far more ammunition, 1,880 to 2,880 rounds total compared to the K-84's 400 rounds for all guns combined. This ammunition capacity meant American pilots could afford to take ranging shots, could spray an area where they thought an enemy might emerge, could engage multiple targets without worrying about running dry. Japanese pilots, with their limited ammunition, had to make virtually every shot count. Combined with inadequate gunnery training, this made effective shooting nearly impossible for most Japanese pilots. The ballistics were simpler too. 6 guns of the same caliber, all firing the same ammunition at the same velocity, meant a single aiming point. Japanese pilots with mixed cannon and machine gun armament struggled with different trajectories, cannon rounds dropping faster than machine gun rounds, creating confusion about where to aim. American pilots aimed at a point and knew their rounds would all converge there. Simple, effective, deadly.
Maintenance accessibility reflected design philosophy. The P-51's engine could be changed by removing 8 main bolts and disconnecting a few lines. The entire cowling hinged open, providing complete access. Wing panels could be removed for armament maintenance without specialized tools. Everything was designed for field maintenance by relatively unskilled personnel. The K-84's Homari engine required specialized tools to service and partial disassembly of the aircraft structure to remove. Many maintenance tasks could only be performed by highly trained technicians who were increasingly scarce as the war progressed. When something broke, it often stayed broken because parts weren't available or couldn't be installed without specialized equipment. The electronic warfare dimension, primitive by today's standards but revolutionary for 1945, gave Americans overwhelming advantages. P-51s used VHF radios with multiple channels and clear reception out to 100 miles. Pilots could communicate with each other, with bomber formations, with ground controllers, with rescue forces. They navigated using radio beacons that transmitted from islands and submarines.
Japanese pilots flew with radios that often didn't work, navigated by compass and dead reckoning with maps that didn't reflect recent bomb damage. When American electronic warfare aircraft began jamming Japanese radio frequencies, it made little practical difference because Japanese radios rarely worked properly anyway. The strategic bombing campaign that the P-51 made possible broke Japan's industrial capacity beyond any hope of recovery. By August 1945, B-29s had destroyed over 60% of Japan's major cities, killed hundreds of thousands of civilians, and reduced industrial production to perhaps 10% of pre-war capacity. Oil refineries were rubble. Aircraft factories were smoking ruins. Steel mills were demolished. Transportation infrastructure was systematically destroyed. And through it all, P-51 Mustangs ranged freely, shooting up anything that moved, attacking airfields, strafing trains, sinking small vessels in coastal waters. Japanese fighter opposition had been eliminated as a significant factor by July. The few aircraft that did rise to challenge American formations were shot down with such ease that missions became almost routine. The shock of April 7th, when American fighters first appeared over Tokyo, had given way to grinding inevitability. The Americans would come daily. They would bomb. They would strafe. And Japan could do nothing to stop them. In the decades since World War II ended, only one Nakajima K-84 Hayate survives. It sits in the Chiron Peace Museum in Kagoshima Prefecture, Japan, a solitary reminder of Japan's desperate attempt to match American technological superiority. The aircraft was recovered from a jungle in Papua New Guinea where it had crashed during the war. Years of painstaking restoration brought it back to display condition, though it will never fly again. Meanwhile, hundreds of P-51 Mustangs survive in museums and private collections worldwide. Many still fly at airshows, their Packard Merlin engines singing the same song of power and precision they sang over Tokyo in 1945. The disparity in surviving aircraft tells its own story about relative build quality, industrial capacity, and how each nation valued its technological heritage. The Mustang's impact on aviation history extends far beyond World War II. The aircraft's long-range capability revolutionized fighter tactics and strategic thinking. It proved that single-engine fighters could escort bombers on missions of 1,500 miles or more, fundamentally changing the calculus of air warfare. Post-war fighter designs incorporated lessons learned from the P-51, the importance of range, the value of reliability, the need for pilot comfort on long missions, the advantages of standardized quality production. Several air forces continued flying P-51s long after the war ended. The Israeli Air Force used Mustangs extensively during its War of Independence in 1948. Numerous other nations operated them through the 1950s and into the 1960s. Even after jet fighters made propeller-driven aircraft obsolete for frontline service, the P-51 found new roles in counterinsurgency operations, forward air control, and training. The last military P-51s weren't retired until the early 1980s, nearly 40 years after the first production models entered service. The racing community discovered the Mustang's potential in the late 1940s. Modified P-51s began competing in the Thompson Trophy race and other air racing events. Today, highly modified Mustangs compete in the Reno air races, some reaching speeds over 500 miles per hour, far beyond the aircraft's original design specifications. These racing Mustangs represent the ultimate expression of the basic design's potential, proof that Edgar Schmood and his team created an airframe with capabilities that continue to be explored decades later. For the men who flew the P-51 Mustang over Japan in 1945, the aircraft represented more than just a tool of war. It was the machine that carried them into combat and brought them home. It was the technology that made their impossible missions routine. It was, in many cases, the reason they survived when so many others didn't. Jerry Yellen, who flew the war's last combat mission, spent decades speaking about his experiences. He never forgot Philip Schlamberg, his 19-year-old wingman who died on the war's last day. Yellen eventually traveled to Japan, met with former enemy pilots, and worked toward reconciliation between former enemies. But he never forgot the aircraft that had carried him through 79 combat missions and brought him home safely every time but that last tragic mission. The P-51 was a magnificent aircraft, Yellen said in later years. It was fast, maneuverable, well-armed, and incredibly reliable. But what made it special was that it gave us confidence. We knew our aircraft was better than anything the enemy had. We knew our training was superior. We knew that if something went wrong, if we had to ditch in the ocean, our military would search for us. That confidence let us do things that seemed impossible, flying 1,500 miles round trip over the ocean to fight over enemy territory. The P-51 made that possible, but more importantly, it made us believe it was possible. The shock that Japanese pilots experienced when P-51 Mustangs appeared over Tokyo on April 7, 1945, was ultimately the shock of mathematical inevitability made manifest. They were not simply surprised by enemy fighters appearing where no fighters should be. They were confronted with the brutal reality that their nation had lost the industrial and technological war, and that individual courage could not overcome that fundamental disadvantage. The comparison between the P-51D Mustang and the K-84 Hayate tells a larger story about modern warfare. On paper, the specifications weren't dramatically different. The K-84 could climb faster at low altitude. It might have been slightly more maneuverable in certain conditions. Its cannon armament was theoretically more destructive than .50 caliber machine guns. But wars aren't fought on paper. They're fought with real aircraft, manufactured in real factories by real people using real materials.
American industrial capacity, technological sophistication, quality control, training programs, and logistics and pilot support systems overwhelmed Japan's best efforts. The United States produced 15,586 P-51s with consistent quality, one every hour at peak production. Japan produced 3,514 K-84s of wildly varying capability. American pilots received 400 to 600 hours of training. Japanese pilots received 50 hours if they were lucky, sometimes as little as 30. American aircraft flew with 100-octane fuel from Texas refineries. Japanese aircraft sputtered on 80-octane fuel, extracted from pine stumps. The battle was decided not in aerial combat over Tokyo, but in assembly plants in California, in training fields in Texas, in oil fields in California and Texas, in the research laboratories where engineers perfected supercharger technology, in the institutional knowledge that allowed American mechanics to perform engine changes in 4 hours, while Japanese mechanics struggled for days. The P-51 Mustang was simply the physical manifestation of American industrial supremacy. When American fighters appeared over Mount Fuji, they brought with them a message that no amount of propaganda could refute. The war was lost. The divine wind had been conquered by industrial mathematics. The warrior spirit had been broken by production line efficiency. The empire of the rising sun had been overshadowed by wings of aluminum and engines of steel. Flight Sergeant Isamu Tatanimitsu, who survived the war and lived into his 80s, never forgot that morning when he saw American fighters where American fighters should not have been. In interviews decades later, he would speak quietly about the moment when hope died, when he understood that courage and dedication weren't enough against an enemy with such overwhelming material advantages. "We fought with everything we had," he would say. "We flew aircraft we knew were inferior. We accepted fuel that we knew was inadequate. We went into combat with training we knew was insufficient.
We did this because it was our duty, because we loved our country, because we had no choice. But the moment I saw those Mustangs over Tokyo, I understood that our sacrifice was meaningless. The war was already lost. It had been lost the moment America's industrial might turned its attention to building weapons. We were brave, yes, but bravery alone cannot overcome the mathematics of total war. The P-51 Mustang over Tokyo represented the culmination of a uniquely American approach to warfare. The application of industrial capacity, technological innovation, and systematic training to create military superiority so overwhelming that individual battles became formalities rather than contests. The Japanese pilots who faced those silver fighters in the spring and summer of 1945 were not defeated by better pilots or superior tactics. They were defeated by assembly lines in California, by training programs in Texas, by oil wells in Oklahoma, by a system of industrial warfare that they could not match and could not defeat. In the end, the shock of American fighters over Tokyo was the shock of facing technological inevitability. The age of the samurai had ended, the age of the production line had begun, and the machine gun fighters, the P-51 Mustangs that appeared where they should not have been, were proof that in modern war, the factory floor matters as much as the battlefield, that logistics defeats courage, and that industrial mathematics, properly applied, is irresistible.
The lessons of those desperate spring days in 1945 echo through military history. Technological superiority without adequate numbers is insufficient. Numbers without quality are meaningless. Training creates capabilities that courage alone cannot match. Logistics and industrial capacity are weapons as decisive as any gun or bomb. And in total war between industrial powers, defeat is not determined on the battlefield, but in the factories, training fields, and research laboratories long before the first shot is fired. When the last P-51 Mustang landed at Iwo Jima on August 15, 1945, with the war officially over and victory secure, it marked not just the end of World War II's Pacific theater, but the validation of a new form of warfare. The aircraft that had shocked Japanese pilots with its impossible presence over their capital had proven that in modern conflict, industrial mathematics defeats warrior spirit. Technological sophistication overwhelms individual skill, and the nation that controls the skies controls the outcome. The silver fighters over Mount Fuji had delivered their message with ruthless clarity. This was no longer the world where courage and determination could overcome material disadvantage. This was the age of total war, where factories mattered as much as front lines, where training programs determined outcomes as surely as battles, where the hum of assembly lines sang the songs of victory long before the first combat engagement. The Mustang proved that point beyond any possible doubt, and in the shocked eyes of Japanese pilots watching American fighters appear over their capital, fighters that should not exist, flying missions that should be impossible, was written the future of warfare. A future where technology, industry, and training would matter more than any individual heroism. A future where the mathematics of production determined the mathematics of war. A future that had arrived over Tokyo on April 7, 1945, carried on wings of aluminum, by engines singing songs of inevitable victory.